So yesterday and the day before, and it feels like the day before, it took us forever to write this one page of notes. What was the last thing we wrote on page 22, by the way? I know we're flipping. I just want to make sure this class. Perfect. You got it all. The very first question on page 19 starts to tell, where are we? So 19 says, an unconformity, which is a buried erosional surface, provides evidence that. So I want you to, when you see a vocabulary and you're not 100% sure what it means, what you need to do is flip back to where we took the notes on that. An unconformity is just a buried erosional surface, meaning erosion happened one day, and then a million years later, it got covered up. So a glacier came through, left behind its U-shaped valleys, its striations, and all that goodies. And then within the next million or so years, more sediments got deposited on top of that U-shaped valley, and more layers started forming. But the key is that an unconformity is a gap in the geological record. I described it yesterday like a missing chapter of a textbook. The chapter's missing and you don't know what was in it, but you knew there was missing pages. So based on that, what do you guys think for number one? An unconformity, is it evidence that a part of the geological record has been destroyed? Many life forms have become extinct. Metamorphic rocks have formed from sedimentary rocks, or faults are older than the rocks they're found in. Like by definition, which one of these is an unconformity? Go back to page 22 if you need to reread it. This caused by erosion. It's a gap in the geological record, missing part of the record. What is that? A, yeah, so that's a geological record has been destroyed, just like ripping out the pages of a textbook. It's destroying them. I'm going to model for you how to answer the next sets of questions because I'm assuming some of you struggled with it. I'm going to show you how I think you should answer them. Like answering them is not as simple as just circling the right answers. All right, so first of all, it says the diagram below represents a cross-section of a portion of the Earth's crust. Points A through D represent locations on the bedrock. The rock layers have not been overturned. So first of all, a cross-section is like someone took a giant knife and cut through the earth so you can see the side view of it. And then they're telling you points A through D are positions in the bedrock. Anyway, it asks which one formed most recently. By the way, when they say most recently, are they talking about the oldest rocks or the youngest rocks? Youngest. I sometimes, depending on how much I want to think, write that down. I just give myself a little note that we're looking for the youngest. You don't have to do that, but that way I don't have to think again. So then they're asking about limestone, siltstone, shale, and gabbro. So there is a key here. I also want to point something out. So here, teachable moment right now. So even though it looks like I'm going over homework, I'm also teaching you something. These symbols, yes, this one gives you the key. But if you remember back to when we talked about rocks, remember when I talked about this last column and I said just ignore it? Okay, so now you gotta stop ignoring it. So if you ever see bricks, where are we? Bricks, they make limestone. So on this one, we've got bricks. This one gave you the key that they were limestone, but you don't need the key. So if they don't give you the key, you look on page 7 of your reference table. So just wanted to point that out. So they're asking limestone. So this is answer A. I'm going to go right ahead and label that. That's answer A. Then answer B is siltstone. That's this one. Then C is shale, and answer D is gabbro. And again, we're looking for the youngest. Which one is definitely not the youngest? A is definitely not the youngest. Why? Because it's at the bottom. Oh, okay, letter D, got it. Yeah, so that's definitely not the youngest because it's at the bottom. And there's one more that is definitely not the youngest that you don't even have to think too hard. Which other one is definitely not the youngest? The siltstone, answer B. Why is siltstone definitely not the youngest? It's below something. C is definitely younger than B. So now we're left with these two spots, the shale or the gabbro. I want you to stop and think about some of the drawings we did on page 17. Page 17, flip back if you need to. Which layer, which one is younger, spot C or D there? And I'm going to ask you why. D is youngest. D is the youngest. But my question is, how'd you know? That's not how you knew. The little marks, the contact metamorphism. I called them whiskers when I taught it to you, but those little lines, they're like the burn marks. They're when I was lava and I walked through and I touched you guys. I burned the shoulders. These are saying that D burned C. If D burned C, then C had to be there to get burned. So those little marks are the contact metamorphism, and that means D changed C. So C had to already be there when D got there. Done. It took me that long to do this, even when I did it on my own. You have to go back and look at every single answer to see if that's the youngest. All right, for the next ones, the diagram below represents a geological cross-section, a portion of Earth's crust in New York State. Letters A through E identify specific rock units. The layers have not been overturned. Oh, and it does say we're doing questions 3 and 4. All right, so I want to take a moment to look at this picture. What in the world is going on here? What's some weird things that are in this set of rock layers? Because remember, rock layers are supposed to be horizontal. That would be undisturbed. So something, first of all, there's a cut in the middle. What is that cut called? Nope, the cross section is this whole picture. The cut, what does it do? So we drew a picture of this on page 17, I believe. This is a fault. This is a break. So that cut or that fault is where the rocks got broken. So I got to ask you a question. What's older, the rocks or the break? What's older, the rocks or the break? Rocks, because you have to have rocks to be broken. So just keep that in mind. And then what else is weird in this set of pictures? I can't hear you, but something about the contact metamorphism. This thing right here is not a normal horizontal layer. So that means it's either an intrusion or an extrusion. And remember, if it burns it, it's younger than whatever it burns. So let's go through question 3. Which of these events occurred most recently? So again, most recently, are we looking for the oldest or the youngest, guys? Youngest. I, again, just jot that down so I don't have to think about it later. I'm looking for the youngest. So what you have to do here is process of elimination. Let's look at answer A. Faulting of rock units B, C, D, and E. So the faulting is the break. Is that younger or older than the intrusion of basalt? So this is the basalt. What's younger, the break or the basalt? How do you know? Can't have a break without the rock. So we know the break is younger. So right now I can cross off B because B is older than answer A. How about the formation of C? Is the formation of C younger or older than the faulting of C? Older. How do you know it's older? Got to have the rocks there before you break them. And then finally, the metamorphism of granite. So looking on the key, granite is this guy down here. The metamorphism is where the whisker is touching it. Is that younger or older than the fault? Older, how'd you know? Can't touch it, can't break it if it's not there. So the rock is older than the fault. Again, guys, it took me looking at all 4 answers to decide which one was really the youngest. All right, which evidence indicates that there's a gap in the geological record represented by this cross-section? Gap in the geological record sounds familiar already. What's a gap in the geological record called? Oh, I love it. You're flipping back to page 22 if you don't remember. That's an unconformity. Well, that's not an answer. But which one of those is the definition of an unconformity? D, a buried erosional surface. Question 5, I had lots of people ask me for help on this one. Diagram below represents layers in the sedimentary rocks from different locations. 4 of the rock layers are identified, A, B, C, and D. No layers have been overturned. So let me just explain what's going on here. They're saying this was found, let's say, in Delavan. This one was found in Arcade. This one in Yorkshire, and this one in Machias. All the areas are pretty much the same. Pretty much the same weather happens in all 4 of those places. Pretty much the same type of climate. Say if there was an ocean covering here, there was an ocean covering in Arcade and Delavan. So it's basically the same spot. But what could have happened is over in Machias, a river might have removed a layer. Over in Delavan, maybe a glacier dropped off some sediments that didn't get dropped off here. So there's some different layers going on, or maybe I didn't dig down as far. But in the end, it's asking which layer is the youngest. And what do you normally do to look for which one's the youngest? Where do you look for the youngest layers? On the top. So I look, oh, I'm like, oh, A's the youngest. Oh, wait, no, C's the youngest. No, D's the youngest. Because all 3 of those ended up on top. We got to go through process of elimination. Which one is really younger? And one thing we can use to help are these fossils. I don't know if you even noticed that there's a fossil there, there, and there. So what we look at is A younger or older than that fossil? A is younger than that fossil. So if A is younger than that fossil, here's that same fossil. Remember, that's an index fossil. So anywhere where you find that fossil, you know it's these are the same age. Anywhere that has that fossil are the exact same age. So these 3 layers, I already know how old they are. So I got to decide, no, I already know that A is pretty young. So let me look over here. A or C younger over here? C. So we know right away without too much thinking that C is younger than A. So I know that letter A is not the youngest. Now I look over here, is D or C the youngest? D is even younger than C. So now I know that C is not the youngest. So I have to decide, is it layer D or layer B that is the absolute youngest? So here at B, what do I know about B and this fossil? B is older than this fossil. So if B is older than this fossil, and over here, this fossil is even older than C and A, what about B? B's a lot older. That if B's older than this fossil, it's down here somewhere. So there's another layer down here that would be B. So what's older, B or D? B is older. So I'm sorry, we were looking for the youngest. So the youngest is D. You got to go through that whole process. It's annoying. That always shows up on the Regents. We're going to practice this a lot though. There's a whole lab. All right, this one's not so bad. Which one's the youngest? A. Couple reasons. A's on top. That's it. Honestly. And then this one asks, which one occurs most recently? The fault, the intrusion, the deposition of A, or the sedimentation of B? So I want to know, is it the fault, the intrusion, A, or D? Right away, which one's definitely not? D is not, because D is at the bottom. No thinking required. How about the fault or the intrusion? Here's the fault, here's the intrusion. Which one's younger? What didn't happen to the intrusion? Didn't get broken. So it happened after. The fault came around, broke the rocks, and then the intrusion went over the break. So now I get to decide, is it the intrusion or layer A that's most recent, which means younger? Everyone stop and think. Take a look at A. There is a huge hint. It's got the touching on it. Like it. Those contact metamorphism marks on A are burn marks on A. So if A got burned, is it younger or older than E? Older. A is older because it got burned. So that means that the intrusion is younger. Even though it's below it, the intrusion is younger. What, just say it, Shelby? Can't burn something that doesn't exist. That is a concept you're going to have to keep repeating. As annoying as this is, once you stop and think about it, you can't break something that's not there. You can't burn something that's not there. So you can't tilt something that's not there. So whatever is burning, faulting, tilting is always younger than what it's touching. Obviously, we're going to need lots of practice. Those of you who've been in lab already, this is what we've been doing. So we started this today. Did anybody have Mr. Miga yet today? None of you guys have Mr. Miga for lab? Okay, never mind then. I know Mrs. Saley's group started this and my group started this. All right, we're going to do some more practice with this kind of stuff. If you could turn to page 21. And before we even start on page 21, I made one simple mistake. See how there's all these boxes down here? The top one, can you add a line so that we're basically making two boxes out of that top line? So all I did was down the center of that first set of boxes, added a line. So now that there's one extra set. Everybody add that line for me. All right. So here we have another cross section. Again, these are called cross sections. It's like I took the earth with a giant sword and cut it down so I can see what it looks like on the layers. And the directions, again, I forgot to write the directions. So what we're going to add are the directions that say, put these in order. In which they formed, which is a weird way of saying, put these in order in which they formed. What am I starting with, the youngest or the oldest? Oldest. So we're going to put a label here. This is going to be the oldest, and a layer at the bottom. This is going to be the youngest. So we're going to need to put these rock layers in order, starting with the oldest and going to the youngest this time. I'm also going to warn you guys, remember my #1 rule of earth science? Read the directions. Read all the words. So this time the directions say put in order in which they formed. Sometimes they might say it a different way. So always read the directions. So we're going to just start with the rock layers. We're going to put them in order in which they formed, starting with the oldest. Where do you look for the oldest? The bottom. What's the problem with this picture? There's a fault. The fault broke the rocks, and not only did it break it, but that they didn't overturn it, didn't flap them completely over. But what happens is the rock layers shifted a little. So one got pushed up and the other one didn't. I don't know about you, but I don't have much of an imagination. And it is hard for me to just look at this and say, okay, which one really is on the bottom? And maybe it's not for you, but let's pretend it is. And if you could flip over to page 23, you'll see the exact same picture blown up and by itself. Gently rip that out. So for the next 10 minutes, are you freaking kidding me? I feel like I went through those directions pretty slowly, Jake. I noticed. All right. I will come around and help you guys put your packets back together. So again, we have the exact same picture. Sometimes I don't understand PowerPoint. What we're going to do is make this easier to see what it used to look like so that I can put it back in order without thinking too much. So we're going to spend the next 10 minutes kind of chilling out on our side. By the way, I'll get it out of the way. You don't have homework tonight either. So we're going to start by color coding this. I like to start with that intrusion. So I grabbed an orange or a red or a pink, but you can do whatever color floats your boat. No, there's no homework. Thanks, guys. I really appreciate it. So start by color coding it. We're going to start with the intrusion. Now I'm going to teach a little bit while you're talking. Yeah. I'm going to talk and I kind of want you to listen. I keep calling this an intrusion. Vocab test. There's an intrusion and an extrusion vocab word. What's the difference between the two of them? Okay, so an intrusion forms inside the earth and an extrusion forms outside. What? Yeah, so the intrusion stays inside, the extrusion makes it to the surface. But if you guys remember when I played with the Play-Doh, even the extrusion will get covered up with layers later on. How can I tell by looking at this picture that this one never ever made it to the surface? This is something you'll have to do. So this, I'm legit teaching teachable moment here. How can I tell that this never ever made it to the surface? We went over this the day we played with Play-Doh. Okay, go to page 17. No, go to page 17, everybody. Not the cut, no. Go to page 17. The whiskers. What about them? They're touching everything. If this was an extrusion, meaning it made it to the surface, there'd be nothing to burn on top. So the fact that this has whiskers all around it, or contact metamorphism all around it, it means there was always rocks around it. If it was bald, that means it made it to the surface. And we're going to practice that a lot. All right, so we're just going to continue on coloring. You can use the same colors I did. You don't have to. So I skipped the one that has the little bubbles in it. If you don't want to, you can color it. But notice that the layers don't line up right now. Yes, they're already coated with their symbols. We're just making it easier to see. And as much as I know you love coloring, we only have about 8 minutes left, so you need to kind of speed it up. Okay, then you can just keep going. So in the end, you're gonna have all the layers colored. I did leave the one very bottom layer white, but that was just me. If you want to color it, go for it. If you're still coloring your first layer, you're going to need to speed up your coloring. Mrs. Ritz? Yes, yep. Yep. That's okay. Okay. Gabby, they need you in guidance. So you can watch the video for that. Guys, if you're not almost done coloring, you need to speed it up. Does everybody have scissors now, or is there anybody that's missing scissors? Anybody now still missing scissors? All right, I'm gonna move on. Those of you still coloring, you can catch up. The first thing we're gonna do with the scissors is cut out just that little rectangle of what you just colored. If you notice, I didn't bother going along the squiggly line on the top. You can, or you don't have to, it doesn't matter. And I'm gonna end up throwing away the key there, so you don't need to keep that. So you're gonna make it look like that. You're basically cutting out just the color area. I just went straight across the top. You can, or you can follow the squiggly lines. I don't care. Just cutting out the rectangle. Or square. I think it looks like a rectangle. Thanks, Mr. D. Yes, guys, can you please make sure the garbage doesn't end up all over the place? Yes, I apologize for the infant size scissors. And those of you who have the larger scissors, you'll notice they don't cut very well either. Oh, no, I worked with what I was given.
Did you ever do more than Mr. Smith's turn? What? Did you ever do those more than Mr. Smith?
Yeah. Luckily, I'm not asking for too much here. Cut the rectangle.
I didn't want to do it because I already got it right outside.
All right, those of you who cut this out, the next thing we're gonna do is cut that break right out. So you're gonna take your scissors and cut the fault so that you end up with two separate pieces. You got this. And then the next thing you're gonna do is put this back together, but this time unfaulted, meaning you're gonna put it back so that it looks like it would have before it faulted. Now, I will point out that it doesn't line up perfectly. Try your best. I put tape on almost everybody's front. Yeah, that's my problem. Okay, go back, no, we're not done. Now we're gonna go to our paper. And we're gonna list these in order in which they formed. So looking at this and the key, oh, so now you can go to this page. So you go back in your packet to page 21. And looking at the key that's still on page 21, which layer happened first? The conglomerate. So you're going to write in that box, conglomerate. Which rock formed after conglomerate? So that was this one. Using the key and your picture. Shale is on top of conglomerate. Then what?
You're supposed to split the first box in half.
I think this one I gave enough, but maybe I didn't. Maybe I didn't. What was after shale? Sandstone. After sandstone was? Siltstone. Then what? Limestone. Then what? Breccia, good. What happened after the breccia? Did the fault or the intrusion come next? How do you know the intrusion was next? So I'm going up here. Not because it has the whiskers. Because it's been cut. Then what? Then the fault. You guys have an extra box now, right? What's the very last thing, Riley? Erosion's happening on the top. Notice that it's not a perfectly straight, flat line. Riley knew because she's been in lab already, that's all. So if the rest of you didn't know that, that's okay. That's where we're gonna stop as long as you have that first column filled out. Knock it, Trent, stop. Yeah, well, it's obviously none of your business. Trent, I need you to stop.
Trent didn't cut it.